Citrix Ready program. Citrix Ready is an end-to-end partner program that showcases and recommends third-party products, solutions, and services, demonstrating compatibility with Citrix solutions. The Citrix Ready designation is awarded to third-party partners such as Mirantis that have successfully met test criteria set by Citrix and gives customers added confidence in the compatibility of the joint solution offering. As you can see on the slide, the links below, if you'd like additional information on the program or specific or additional information around the Citrix and Mirantis partnership, you can go to the marketplace. If you're interested in submitting questions, we will answer questions at the end of the presentation. What you need to do is just go to the question window, which is located in your GoToWebinar interface. As you can see there in the question window, and just go ahead and enter your question. And again, we'll address those at the end of the presentation. I'd like to introduce our speakers today. Today we have Michael Leonard from Citrix. Michael is the product manager with our Delivery, Network, and Cloud business unit. Michael has the primary role for SDN and cloud marketing for the Citrix NetScaler Application Delivery Controller, and has a background in application performance management, software-defined networking, and cloud computing, as well as data center switching. You can follow Michael on Twitter. Kamesh Pemaraju is the Vice President for Product Marketing and Technology Alliances at Mirantis. Kamesh draws on his strong knowledge of emerging technology markets, broad open source experience, and technical consulting background. And you can also follow Kamesh on Twitter. So the agenda today, I'd like to provide a brief overview on the Citrix and Mirantis partnership. Then I'll turn it over to Kamesh to provide an overview on Mirantis. Then we'll have Michael talk about the OpenStack NetScaler integration and capabilities, and finally we'll wrap up with the Q&A. So there's definitely a strong partnership between Citrix and Mirantis to serve our customers. As you can see from the slide here, we've had a lot of exciting activity around the joint partnership. A couple things that I'd like to highlight on the slide. The first one being Citrix NetScaler, which is Citrix's leading network solution, is officially certified to run on the Mirantis OpenStack distribution, marking the first integration of its kind for Citrix technologies. As part of the certification, Citrix is also part of Mirantis Unlocked partner program, which enables both companies to work together to provide interoperability, enterprise readiness, and best-of-breed technologies for enterprise customers. Mirantis, as I mentioned earlier in the presentation, is also a verified Citrix Ready partner as well. As part of our engagement, we also developed a joint Citrix and Mirantis unique and valuable white paper showcasing best practices for NetScaler and Mirantis OpenStack implementations. At the end of this presentation, we will provide a link to this white paper. Again, as you can see from the slide, there's been a lot of exciting activity around the partnership. We are excited about the power of the joint solutions. And with that, what I'd like to do now is turn it over to Kamesh to tell you a little bit more about Mirantis. Kamesh?
Thanks, Amanda. If you can go to the next slide. Okay, so I guess I'll start by giving everyone a brief overview about Mirantis and then jump into the topic of today's conversation, which is really all around building large-scale clouds, what we call web-scale clouds using OpenStack. So quickly, to talk about the Mirantis point of view and strategy around OpenStack, our goal really is to help our customers build their own AWS-style cloud. A lot of users go to AWS for its convenience, ease of use, and just the scalability of the cloud platform. And of course, that is something that many IT departments around the world and even telcos and others want to replicate within their own data center for a variety of reasons: compliance, regulation, regulatory requirements, and basically, you know, being competitive with their own business offerings on their own platform in a cost-effective way. So that's really what we want to enable our customers to build an open cloud that is AWS-like, and of course, in the end, help end users, who in this case are software developers and infrastructure operators, the ability to innovate in their own terms and also build software faster. Our brand is all around pure play OpenStack. Pure OpenStack is all we do. That is our one and only focus. And you can see all the work we've done in the community We are the top 3 contributor to the OpenStack code base. We are the source of the source code, as we call ourselves. Everything is 100% open source. There are no proprietary bits. Everything you see from Mirantis is either in the upstream code base or we have made changes based on customer requirements that we then contribute back to upstream. So everything is 100% open source. In terms of creating end-to-end solutions for our customers, we partner with the best-of-breed companies such as Citrix and bring those end-to-end solutions to the market. So whether it is load balancers on the top of the stack, or whether they are network storage or compute solutions that OpenStack consumes, we have a partnership program that Amanda was referring to earlier called Mirantis Unlocked, which enables us to integrate and interoperate and use those solutions as part of OpenStack. So pure play OpenStack is the key kind of value proposition that we have. And the last one is very important for this discussion. Again, when we build clouds, we're really focusing on large-scale clouds, right? I mean, when we talk to large enterprises and telcos and communication service providers, they're not building 10-node or 20-node clusters. They're building thousands of nodes of OpenStack clusters distributed across multiple data centers. And of course, what they want is that it is easy to operate, that they can easily onboard applications to this cloud, and more importantly, they're able to operate and manage it at scale. And all of this has to be resilient and it has to be highly reliable. So those are the tenets with which we have been focused on OpenStack. So next slide. Very quickly about what Mirantis has been up to last year and this year. We have been growing quite rapidly. Now, in fact, these numbers are already outdated. We're 800 plus employees around the world. We have opened new offices in Tokyo and in Europe. We have seen some really excellent customer traction in the last couple of years, many of them building large-scale clouds. We have stricken some really good partnerships, Citrix, of course, being one of them, but we've been working with Google, Juniper, Cisco, EMC, and NetApp, and a number of very large vendors in the infrastructure space, bringing them into the OpenStack community and integrating their solutions with Mirantis OpenStack. So I think the main thing that people may not know about is, as Mirantis actually started as a services company. In fact, we are still a very strong services group within Mirantis that provides large-scale OpenStack expertise. But we are really focusing on the product. When I say product, it is the OpenStack distribution from Mirantis. This is the code that you can download from our website, deploy it either on your own or with the help of Mirantis using what we call Fuel, which I'll touch upon in a second. But like I said earlier, our goal is to build this distribution such that it is hardened, it's tested at scale, it's resilient, and of course I mentioned best-of-class partners. So this is kind of our goal, and we have been working very diligently in this direction. And as you probably know, most recently we also had another boost of investment from Intel and other partners, which really enables us to take OpenStack to the next level, make it enterprise grade and resilient at large scale. Next slide. So these are some of the things we have been focused on, and it's very relevant to today's conversation because a large number of our customers who have bought in to the OpenStack vision are really looking to build these large-scale clouds. So in terms of the overall solution that Mirantis brings to our customers, obviously there is the distribution itself, which is our latest version, 6.1. Web scale architecture, easy to scale and install, large number of third-party vendors, drivers, and plugins that have been certified. But again, the more important thing is OpenStack, while it's come a long way in the last 5 years, is still not easy to deploy and operate, especially at scale. There's a lot of considerations, and I'll get into this in a second, and best practices and things you have to think about when creating large-scale data centers that and OpenStack deployments. Production at various very large, brand companies. And these folks know how to build these clouds. We have consolidated many of the best practices, which you will see in the white paper that Amanda was referring to earlier, and also we'll touch upon some of those today. And in conjunction with NetScaler, you can actually get a very nice solution in terms of managing your application delivery and your quality of service requirements all the way up and down the stack. So we have training, and there's a new program called Appliances, which we can talk about later. So if you go to the next slide, I want to touch upon briefly on the requirements for large-scale clouds. So this is it's not as easy as it sounds. Building resilient clouds, especially on OpenStack, and understanding the various requirements, starting from the bare metal up. And this is an important thing. People that focus on the software or the middleware or the operating systems don't necessarily understand all the nuances and complexities of building the data center itself such that it is resilient, right? So there are key requirements here, of course. When you're building a production cloud, you do want to minimize your downtime, and more importantly, you want to prevent data loss. Now, typically, in any data center that runs, cloud-like architecture, people often think that they're all just cloud-aware or cloud-native applications that are all stateless, and it's the pet versus cattle kind of analogy where it doesn't matter if one of the VMs goes down, your application continues to run, there's no problem. But that's not necessarily true all the time. There are state-dependent applications. There are databases in the system. There are things that you have to kind of make them more resilient and redundant, even when they're stateful, or state-dependent, if you will. So it's necessary to support both, because that's the reality of the world out there. You'll have both types of applications. People are bringing in quote-unquote legacy applications to the data center, and in fact, there are many customers of ours who want to run traditional applications in OpenStack. Now, a few years ago, we would have said, that's not such a great thing to do. OpenStack is really for cloud-native applications. It isn't really built for cloud state-dependent applications. Maybe VMware is a better deal. But now we're seeing a lot of customers wanting to do that on OpenStack. So it's good. It's important to be able to support a mix of both type of applications. Now, obviously, multi-tenancy would be key for service providers, especially, and even for enterprises that are supporting multiple departments and multiple zones or multiple user bases within their enterprise. So OpenStack projects is a way for providing multi-tenancy so that they can all share the underlying infrastructure. And application acceleration, once you have the cloud up and running, then you're talking about how do I optimize and accelerate my application and load balance all my services, especially when you have multiple data centers and your services are distributed geographically across multiple locations, etc. This is where NetScaler comes in, and we'll talk a lot more about it in this presentation. And then, of course, there's the whole question of quality of service and performance SLAs, especially when it comes to network-heavy applications where you need the network bandwidth. Sometimes you need wire speeds. For some of the telco customers, when they run some of their, what we call virtual network functions, for example, that do need very high levels of network performance and storage performance. So how do you comply with those? And I mentioned about cloud services in multiple locations, which is actually pretty common, you'd be surprised, especially with large enterprises. So let's quickly look at, if you can go to the next slide, Amanda. So there are a couple of things, high-level considerations. There's definitely more information in the white paper, so I'd encourage you to download and take a look at. But there are some things you need to consider, right, in terms of best practices. So when you're creating your data center, let's say you're creating this cloud infrastructure in your data center, what are some of the things to think about? Now, OpenStack has something called availability zones. This is the way you segregate your physical resources into pools, right? You have pools of compute and storage. The idea behind this is you don't want any single point of failure. So if your power supply goes down, you don't want the entire cluster to go down. Or if your networking connections, one of your switches goes down, top of rack or something, you don't want the entire cluster to come down. So the idea is to segregate your physical resources and then using the concept of OpenStack availability zones, you can then segregate them at the abstraction layer. So you can create an availability zone, for example, that could be within a certain rack, as an example. Now, in addition to that, you also have to think about high availability, right? So if one of your compute node goes down, or one of your control plane clusters go down, or nodes go down, how do you make sure that your system continues to run and you have minimal or zero downtime? Now, this is why you need to think about distributing your OpenStack services, your control plane, if you will, and any databases and messaging that it uses. And in the next slide, I'll quickly talk about some of the things we're doing in this area across multiple time fault domains. So if one of the domains goes down completely, you're still operational, right? So that's at the OpenStack control layer. And then now you have to start thinking about what happens at the control plane or the data plane, right? Now, especially for networking fabrics, if you're using some kind of a overlay networking technology or an SDN solution, the same considerations apply, right? You want to scale, and at the same time, you want it to be resilient to failure. So the control plane of your SDN also similarly needs to be distributed across multiple fault domains. The same thing applies to storage. And it looks simple, but in reality, when you implement it, all these considerations have to be thought through across the entire stack, starting from your compute node to your racks, to your availability zones at the OpenStack layer, and to application delivery. So I'll give you a quick example in the next slide. So if we can go to the next slide, how we're doing this with the OpenStack control plane, for example. Now, the OpenStack control plane is basically all the services that OpenStack provides to its end users. So next slide, please. And here, obviously, you need this to be redundant, and you want the services themselves to be resilient to any single point of failure. So in our current design, in our 6.1 release, we have basically 3 controllers, previous slide, and 3 redundant HA controllers that provide you with those redundant services, right? And there are some stateless services and there are some stateful services. In the case of stateless services, we use an HA proxy within the network, within the cluster, so that they are then we can load balance services out. There are stateful components too, such as the database, and you have the message queue and so on, the L3 gateway agent and so on, which are active standby mode, and failover is performed by pacemaker in the case of a node failure, and databases, in this particular case, MySQL, which runs as a cluster using Galera for redundancy management. So this is the way that we are addressing this today, and going forward, we are trying to distribute. In fact, this is actually coming in 7.0, which is our next release, which is due to come out in a couple of weeks. Is the control plane itself can be distributed across fault zones. Now, right now, the 3 nodes for control plane are all together in a single rack. So if the rack goes down, then you lose your cluster. Ideally, what you would want to do is to distribute those 3 nodes across, say, 3 different racks if the rack is a fault zone, for example. And then it's easy if one of these things goes down, you can basically spin up another node with the services up and running there. So again, we can't go into all the details, but this is described nicely in the white paper. You can take a look at that, and our distribution actually comes with the HA option built in. So when you deploy, you can select the HA option, and that'll deploy all the nodes in the HA configuration. So if you go to the next slide, I wanted to quickly talk about how we do this, right? I mean, it's all very complicated. There's a lot of orchestration involved. There's a lot of deployment options that you have to think about and consider. So it's not for the faint of heart, right? So we have taken all the best practices of how to configure, how to manage your cluster, how to deploy it, what are all the various technology choices you can select from what you have in your data center, and more importantly, making sure that all of this stuff works when you deploy it, right? So all that is managed through what is called Fuel, which is our deployment and management tool, which comes bundled with our distribution. And this, when you download the distribution, Fuel comes with it. And Fuel is what you see when you get started with your deployment, right? So it's a GUI-based interface, wizard-like, easy to use UI, where you can kind of select your options, and Fuel does the rest for you. It'll discover the nodes. It'll ask you which of these nodes you want to be compute nodes, which ones you want as your storage nodes, and how do you want to configure your network. And in the end, after you've given all those options, whether you want HA or what kind of storage backends you want, what kind of VLAN configurations you want to set up for your network, et cetera, all of that is managed and configured and guided by Fuel. And once it's all done, you have your cluster up and running. It also does a whole series of health validations, so network verification, making sure that the actual OpenStack cluster is responding, and it goes through a series of tests to make sure that everything is in good shape. This is an important piece of the technology, and this is how we do a lot of our interoperability testing with companies like Citrix, for example. They have their NetScaler product. When we tested, we actually deployed using Fuel, and there are things like Fuel plugins which we can go in later, and if anybody has any questions, let me know towards the end. I think that's pretty much my part of the presentation. Amanda, if you can flip to the next slide. I guess it's Michael's turn now.
So thank you, Kamesh and Amanda. NetScaler plays an important role in the model that we just heard about from Kamesh, and I'm going to cover a few of the features that make NetScaler a good fit for deployments with OpenStack. So first, let's take a look at what NetScaler does. We call NetScaler the universal front end for your applications. Its role is to ensure availability and performance and security for your applications. And NetScaler does this by bringing intelligence to your network and to your applications. They can do things like rate limit access to an application to protect performance, or it can switch content to a different host based on parameters in HTTP or SIP or diameter, for example. And it can do things like traffic management and health checks and application load balancing and DNS caching and other things. But in the OpenStack context, there are some important capabilities that NetScaler brings specifically. NetScaler is built on software, so you get all the same features across platforms, and you have a choice of physical or virtual appliances. Our VPX appliance is software only, so it can be auto-instantiated in OpenStack environments. And our SEX platform provides consolidation where you can run many VPX instances to serve multiple tenant groups under centralized management, and it has the hypervisor and the management built in. Our MPX platform is a hardware appliance where the hardware is tuned for application delivery controller workloads to provide the best performance. And NetScaler platforms can be clustered in a scale-out model to serve large-scale applications that are built for the cloud and provide resiliency with up to 32 nodes in a cluster as a single logical unit. NetScaler supports a pay-as-you-grow licensing model on all of the appliances where additional capacity can be unlocked on any device simply by applying the corresponding license. And it supports things like a bursting mode and also a subscription licensing model. So it's ideal for all types of business models, including software as a service that may be offered by cloud hosting providers. So the next slide, this is the OpenStack architecture with NetScaler. And we can look here now and see how NetScaler works with OpenStack. And NetScaler's OpenStack solution is based on a purpose-built orchestration platform from Citrix, and we call that NetScaler Control Center, or NCC. And NCC simplifies the operational complexity when you're deploying an ADC like NetScaler in OpenStack. It provides the key functions that enable what we call a cloud consumption model, making it easy for cloud providers to offer any NetScaler ADC or security function as a cloud service. And it's important to know that NCC supports all of the NetScaler platforms, whether they're hardware or software. and it provides a translation between the APIs in OpenStack in the Neutron module, and with the NetScaler APIs. So the entire workflow is automated, and as far as the end user is concerned, they're just consuming the LBAS function, just like any other network function that's offered as a service. NCC applies the right license to the NetScaler instance. It then attaches the instance to the right networks, including both management and the data networks. And it starts, with the creation of a new ADC instance, and then assigns the right resources to it, including CPU and memory and so on. The entire workflow is automated, and the devices under management of NetScaler are treated as an aggregate pool of capacity so that they can serve the entire application deployment as needed. And the automation of the provisioning is supported across all NetScaler platforms, both virtual and physical. But there's still a certain degree of flexibility and control that the administrator has when configuring network services, and these include resources and tenancy. So the administrator can manually decide on how much CPU or memory or throughput should be allocated to a tenant, and then they can decide where to place a newly created load balancer in the data path, and they can decide on the topology, such as if the load balancer should be connected to the server pool on a directly attached network, or if it should be connected over layer 3. And all these decisions are critical to the processes of operationalizing the LBAS functions, so the administrator really needs to have control over them. So we can look at the next slide, and this is NetScaler integration with OpenStack. So this is a closer look at how NetScaler and OpenStack integration works. NCC is a separate service that runs outside of the OpenStack infrastructure. And as it's deployed, it's a virtual appliance, and it's supported on a hypervisor platform like KVM, ESX, or Zen Server. And NCC provides the connection between OpenStack and NetScaler, and it provides advanced functionality to translate API calls and ensure that the features in NetScaler can be accessed. And NetScaler Control Center supports OpenStack through an integration with the LBAS service, which is a sub-project within Neutron networking. And like other modules in OpenStack, LBAS can be plugged in by third-party vendors such as Citrix. And the LBAS integration consists of a driver class that implements Neutron LBAS, and the driver calls NetScaler Control Center using REST APIs in NetScaler. So Citrix developed the driver for the plugin, and we've submitted the code to the community. And this was part of the OpenStack Icehouse release in April of 2014. And NCC provides an orchestration service that takes the task of correct configuration of the NetScaler devices, and it manages resources like CPU and memory allocation and tenancy for multiple tenants. And it has capabilities like to include the rollback in the case of failure, and detecting configuration drift and of operation, and collecting statistics for troubleshooting. So we look at the next slide now, automated NetScaler provisioning. There we go. So provisioning includes everything that you need that you might do during a manual configuration before you configure the load balancing policies. And it starts off with the creation of the ADC instance and then assigns the resources. NCC applies the license then and attaches the service to the right network. And it automates the entire workflow. So the devices are treated as an aggregate pool, so they can be used by any application. Again, there's a certain degree of flexibility. The administrator can have manual control over things like tenancy and where they put the load balancer in the data path, and they can decide on the topology. So now we can look at the next slide, which is sophisticated placement logic. Okay, so to ensure high performance, NCC provides support for multiple placement algorithms in the data flows, and these include things like round robin or least utilized based on your VIP count or your CPU utilization, or SSL utilization and affinity, which can be specified by the rack or the point of delivery or an availability zone, as well as being determined by external input from the operator. And NCC supports an active-passive redundancy model, so it can survive failures in a fault domain. And okay, now we can look at the next slide, which is customizable isolation policies per tenant. So NCC is designed to provide isolation policies and hardwall resources per tenant, and it can use the aggregate capacity of all of the NetScalers that are under management. So the administrator can decide between several options for dedicating ADC resources to the tenants. They can allow for a fully dedicated NetScaler instance with specific resources allocated for a certain kind of tenant, and this is the highest form of isolation. It allows each instance to be completely hard-walled as far as CPU and memory and SSL capacity. And the policies can also allow instances to run their own versions of the software, so they can be maintained and upgraded independently. NCC allows you to create dedicated virtual appliances with NetScaler VPX, as well as dedicated instances on our physical multi-tenant platform, which is the SDX. But if you're looking for a high-density multi-tenant solution, you can also choose dedicated partitions within the same NetScaler instance. And each partition can be assigned dedicated bandwidth connections per second, and they can have isolated memory space, and each partition can also support overlapping IP addresses. And the partitions can be created on any of the NetScaler appliances, whether the MPX or the SDX or the VPX. And finally, the operator can choose to share the same instances across multiple tenants. And these different capabilities are not mutually exclusive, so you can use any or all of them as you choose. So the next slide is guaranteed SLAs. And this is the last topic I'm going to cover. With NetScaler policies, you can create them to guarantee SLAs to your OpenStack tenants. And the flexibility model allows the administrator to maintain complete control over how the load balancing capacity is utilized by the different tenants. So the admin can create several different tenant tiers or tenant types, and then assign different ADC resources to each tenant. And this is done before the tenants start using the LBAS function as part of the pre-provisioning of the workflows. And different tenants can have different SLAs, and they can be defined as service packages within NCC. So you might have a red tenant class that gets a dedicated SDX instance with a certain amount of capacity, like 2 cores and 5 gigs of throughput. But your green tenant might have something less, like maybe 1 CPU or just 3 gigs. And your blue tenant might just have a best effort type of guarantee or no guarantee. So that's all customizable based on any of the capabilities within NetScaler. So that's it for my part. I think, Amanda, we're on to questions now.
All right. Thanks, Michael. Thanks, Kamesh. So as you can see here on the next slide, the white paper that we did reference, this is the link to the slide. I understand the Citrix Ready team will also make this slide deck available, so you'll be able to reference not only the links, but also the context listed within the slides, or this specific slide. As Michael mentioned, what we would like to do is to open it up to Q&A. Michael, we did have a question that came across on the webinar. For those of you who still have questions, please go ahead and type them into the question window. So Michael, the question that came across was, do I need to over-provision the NetScaler hardware to cover my ADCs as a service consumption, or can I procure the hardware and pay based upon what I consume from those NetScaler appliances?
We have a capability called Autoscale. So you can set up Autoscale so that as you have more tenants come on or more workloads, that NetScaler can turn up automatically, and through OpenStack, new instances can be instantiated. So the answer is no, you don't have to over-provision. We have also on the licensing, we have the subscription model. So you'd be charged based on the number of instances that are turned up through Autoscale. So both the licensing and the instantiation can be automated to suit your cloud application.
Okay. And again, if you have questions, please go ahead and put them in the chat window so we can view them there. Kamesh, I have a question for you. How do you scale the ADC services to correspond with the needs of the application and the availability model of the application?
Yeah, I mean, basically, as I said earlier, you create fault domains that are self-contained units that are designed to fail independently, and that should also be the case with the ADC services, right? So what that means as a typical best practice is that for each NetScaler in an availability zone, it's load balancing traffic to that local compute farm within that zone, right? Instead of load balancing across other zones, right? So this allows NetScaler instances in one fault domain to fail over without impacting to the other fault domain. So this is in keeping with the best practice of, you want to keep everything within that particular fault zone so that you have high availability. Of course, I'm talking mainly about stateless applications, but if you have highly stateful applications, then you could make an exception and kind of think of other alternatives.
Okay, thanks, Kamesh. Michael, if we can, put you on the spot again and ask you another question. Can you tell us a little bit more about how do you distribute the NetScaler data plane across multiple availability zones in the multi-data center model?
Sure. So to distribute a data plane, you need an external device. So it could be your upstream router or your switch that's distributing the traffic. And you can use equal cost multipath, or EMC, which is a common distribution mechanism at layer 3, and it's supported by all routers. So a typical deployment would be for the upstream routing layer, like say the data center core router, to use ECMP to distribute the traffic to all of the NetScalers across the multiple availability zones. And since EMC is stateless and it's based on a hash mechanism, it's what we call flow safe. So it'll always ensure that the traffic from the same flow is processed by the same NetScaler.
All right, thanks, Michael. Since you have the floor, why don't we ask you another question? How do you support the advertisement of the availability of services running on an instance?
So the service advertisement is done by route health injection, which is another common protocol in switches and routers. And that's a mechanism that NetScaler supports, so it advertises it through a dynamic routing protocol. So you could use OSPF, for example. And the way that RHI works is by having NetScaler inject the routes into OSPF, for all of the services running on a particular NetScaler instance. And when that service becomes unhealthy, as we call it, or goes down, the route's automatically removed from the advertisement, so the upstream router won't send any more traffic to that NetScaler.
Okay, thanks. What about mapping NetScaler Control Center to OpenStack for availability and redundancy?
Well, the recommended practice that we have is to have a one-to-one correspondence between an NCC instance and an OpenStack controller node. So NCC supports an active-passive redundancy model. So for it to survive a failure of a fault domain, you deploy an NCC in per
next question. And again, if you have additional questions, certainly please ask them. To both of you, what is the recommendation for multi DC architectures for OpenStack and NetScaler?
Yeah, so this is a fairly complicated question. So within OpenStack, there are things called Nova cells and Nova regions, which basically allow you to have different ways of configuring your multi-data center control plane and compute nodes across multiple geographical regions. And some of that is not completely baked. I mean, although cells have been around for a while, I personally haven't seen them implemented. So right now, our best practice recommendation is to just have independent OpenStack clusters in different data centers with their own control planes, and that way it's easy to manage and kind of operate within the construct of that data center. Now you could do things like you can share authentication across multiple regions. You can share the user interface services across multiple regions. There are different ways of doing it, but like I said, I guess the best and easiest way to get going is to just have independent clusters in each region.
Thanks, Kamesh. Michael, did you want to add anything else to that? Otherwise, I do have another question.
I think that's good. We can go on to the next one.
Okay. So a question around NCC or NetScaler Control Center. They would like to know if NCC is targeted only for LBAS integration on OpenStack, or are there use cases for using this in pure VMware implementations with NetScaler MPX and VPX?
Yeah, so NCC can be used to connect NetScaler with any type of cloud or SDN type, and so VMware is a good example, and we are working on development of NetScaler with VMware's NSX SDN platform